Here's part A of number 9. So we're asked to find delta r, and to do that you want to subtract one path length from the other path length. So first we're going to solve for this path length in between the two cell towers, and to do that you want to use Pythagorean's theorem to find the hypotenuse. So 40 was given to us as the height of this side of the triangle, and then to get 30 you just divide 60, the distance of the bottom, by 2, and then solve for C, which is this side of the triangle. We get it to be 50, and then we know that we multiply 50 by 2 because this is an equivalent path length to the other cell tower. And then you just do 100 minus 60 because we know that the distance of this path length is 60, and we get delta r equals 40 meters.
So part B asks, if there is destructive interference between the two waves, what is the longest possible wavelength? And here we use the phase difference equation. Delta big phi equals 2 pi delta r over lambda plus little phi. And we use 3 pi to simulate destructive interference, because if we were to use pi, which is the first multiple, then it would cancel out with the pi on the right side, so you would get 2 pi times 40 over lambda equals 0, which is impossible because our delta r isn't 0. So we use the next odd multiple of pi, 3 pi, and the reason why it can't be 5 pi or 7 pi or something greater than 3 pi is because that would result in a smaller wavelength, because the denominator would have to be smaller. So here we solved, and we got lambda equals 40.
Here's part C of number 9. It's pretty much the same thing as part B, but we're looking at constructive interference, so you just have to change big phi to 2 pi instead of 3 pi, because constructive is even multiples of pi, and then you just solve for lambda, 80.